Hello students, I'm back again. This is part 2 of chapter 6, the chemical bonding. So, this is the resonance. What are the resonance? Resonance is one compound by showing in two different Lewis structures. The difference in these two Lewis structures are the position of an electrons only. The two resonance structures differ only by the position of an electron. So you can see this ozone, this double bond is here, and then this is the same compound, you see, but it's they differ in the position in electron, but other than that, there's no difference. And if you think about the carbonate has one carbon and three oxygens, and if the double bond can be into this oxygen, it doesn't matter because it doesn't change the formal charge of the compound. So it can be double bond can be here, bond can be to this oxygen or to this one. Same with the benzene. So I have a question, and this is long description. I'm going to read it from here. Sulfur dioxide is oxidized in the atmosphere to form sulfur trioxide, which subsequently combine with water to produce sulfuric acid, a major component of acid rain. Draw all the possible resonance. So you have to draw sulfate. So let's draw it. Why don't we draw it together? So I have the sulfate. Let's see how we draw sulfate. First, I want to find what is the center atom, which is sulfur. So sulfur brings 6 electrons. Oxygen brings 6 into 4 plus 2 because of this negative charge. 6 into 4 is 24 plus 6, 32. You have 32 electrons. And then you write S, O, 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 and then you write the valence electrons 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. And then, but the problem is in this one, it has more formal charges, and because of that, they come up with the, if you think, calculate the formal charges, and you will find out this structure would be more stable. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4. And then this is the 2 negative. And then this double bond can be here into this oxygen, or it can be, where is it? It can be to this oxygen, and then it changes these. So it can go to all the 4 oxygens. So that is the resonance structure of sulfate. So that's what it's. Oh, sorry, I did for the sulfate atom. That doesn't matter. This is SO3. I thought they asked you to do the sulfuric. Oh, okay. Sulfuric acid. Okay, they ask you to do the resonance structure of SO3. It's not making a big difference. I just draw for sulfate and everything is right. The way we draw the Lewis structure, way I draw the resonance is good. So here you already have the answer for SO3. So that is how you draw a resonance. It's the same Lewis structure, but the position of electrons is different. And now we are still in the Lewis structures, and then this is another scenario. There are some cases, I always say octet rule. Why this atoms bonding to go to the to form 8 electrons? But sometimes think about beryllium chloride, beryllium hydride. They don't have the 8 electrons. They have sometimes 4 electrons. So there are certain atoms, we call them exceptions of the octet rule. Some atoms, they don't go to 8 electrons. Some atoms, they go above. They have more than 8 electrons. And some, we always thinking about even numbers. Some elements even have odd number of electrons around the central atom. They are very unstable. We call them as radicals. So, and then here you see one example. The central atom has fewer than 8 electron and odd number of electron. This is you call nitrous and it's a free radical. And then the other exception is there are certain elements have more than 8 electrons. So we call them as expanded octets. Always if at the expanded, in order to make an expanded octet, the center atom should be period 3 or below. That means oxygen, if the oxygen is a central atom, it cannot have more than 8 electrons. But sulfur, because it's group 3 and below, it can form more than 8 electrons. If you go down, draw the Lewis structure of chlorine dioxide. So chlorine dioxide, the same way you follow, find the lowest electronegative element, which is chlorine here, and then 2 oxygens, and then find the number of electrons. Oxygen brings 6 into 2, 12 plus 7, 19. Always give the 8 electrons to the terminal atoms. Look back the chlorine. Chlorine has 7, so this is how you draw it. It has odd number of electrons. And then I have another example. Draw the Lewis structure of triiodobromide. Boron triiodide. It is boron is group 3, iodide is group 7. So boron brings 3, iodide brings 7 into 321 plus 324. You make the boron as the center atom, iodide, and then you distribute 24 electrons evenly through this boron and iodide. So then boron, iodide, they draw the resonance too. And then I have draw the Lewis structure of arsenic pentafluoride. Let me draw it. Arsenic pentafluoride. Arsenic is the center atom. Arsenic is group 5, right? So then arsenic brings 5 electrons, phosphorus brings 5 into 5, it's 30 electrons. So what I would do, write arsenic, let me see. Okay, this guy, sorry. P5, 5 plus 5 into 5, 30, arsenic. Like that. Okay, and then 30 electrons 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 2. So it's now it's 8 into 5. It has 40. Give me a minute, okay? 40 total. I'm sorry. I'm sorry. I did a mistake here. Calculating valence electrons. So I just want to show you that you see my mistake. AS. No, it's not P, right? ASF5. Sorry, it's not ASP5. It's ASF5. That's why. I was thinking about P5. I'm sorry, I was making videos from the morning. So it is AS is 5 plus 7 into 5. It is 40. That makes sense. So it makes so much sense to me. AS, F, 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 and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you see now, I have all elements have 8 electrons and the 40 is gone, but it's expanded octet. And then you go to the xenon fluoride, the same thing, but xenon brings 8 electrons, fluorine brings 7 into 4, 28, and then 8, 36. And then you may, when you put the 4, so 8 into 4, 32, but you have 4 more electrons remaining. That 4 more electrons is on the central atom. So that's how you draw the xenon fluoride. And then there are certain atoms, they have more than one center atoms. At that time, you just draw, with this question, draw the resonance structure of sulfurous acid, one that obeys the octet rule for the central atom, one that minimizes the formal charges. Determine the formal charges on each atom in both structures. So sulfur, you'd write SO3, 2 minus, because you have two charges, um, two negative charges, so oxygen, sulfur, SO3, and then two hydrogens attached to the oxygen. And then this is one structure, and then you calculate the formal charges. And then, so that's how you do the double bond, and it can be, the hydrogen can go here. That's the resonance. This hydrogen can goes up to this oxygen, and then this double bond be here. That can be another resonance structure. Always keep in mind when you calculate the formal charges, the sulfur is +1. Why? Sulfur has 6 valence electrons, -2 non-bonding, -6 into half. So it's going to be 6 minus 2, 6 into, so basically, let me draw show you how to get the formal charge. So it's, I'm sorry, my thinking not working now. It's okay. So in order to find the formal charge, it's 6 electrons here, 2 non-bonding electrons, so 6 minus 2, 4. And then here you have always 3, 6 into half, so it's going to be 3. So it's 4 minus 1, it's 4 minus 3, it's +1. So it's, again, I'm explaining you. 6 valence electrons, -2, 4. Now you have 4, and then half bonding 6. Half is 3, 4 minus 3 plus 1. That's how we find the formal charge. And always there is exceptions for the octet rule, and then can be expanded octets, less than 8 electrons, and then odd number of species. And I hope these videos will help you to understand the chemical bonding one, that include drawing the Lewis structures. We talk about electronegativity, we talk about um, dipole moment, we talk about percent ionic character and the resonance, formal charges, and by this time you should know how to draw a Lewis structure of any compound. Always follow the rules, including identify the center atom, calculate the valence electrons, and then distribute the valence electrons in the terminals, giving 8 electrons to the terminal atoms. Then come back and look at the central atom. If central atom does not have 8 electrons, you can make a double bond or a triple bond. And if you have any extra electrons, you can always leave on the central atom. So that is the end. Thank you.